Ryan's story is one of passion and expertise in both electrical engineering and software development. Growing up with a strong interest in how things work, Ryan began his career on the factory floor, where reliability was paramount. He soon found himself working on mission-critical projects like retrofitting servo presses at data centers and designing redundant power systems for companies like Google and AWS. This experience not only honed his electrical engineering skills, he's also
So yeah, my actual end goal is to introduce everybody to just a general chat application, and then kind of pivot into something that's a little bit more interesting like this. So this is basically just it's a locally run LLM and a machine learning voice synthesizing tool. And this was all implemented with WebSockets, just like we implemented together in these past couple videos. It's a really cool way to kind of round out your experience, and all of the things, everything that we accomplished in these previous videos will hopefully make this project a little bit less daunting and a little bit less difficult to do. Because this really isn't difficult to do. As you heard, the bot TTS, which was trained on my own like contextual voice data. I am not a developer, and I know this isn't the most impressive application ever built in the world by a hobbyist developer, but you know, I have no professional background in computer science, and this is a pretty cool application in my opinion, and it touches on a lot of very modern, very current, very very buzzwordy concepts and tooling. And I really think that everybody can do this. So it has been my pleasure, and I hope that if I can do it, you can do it. And I hope to see you in the next video. Thanks. Picking up where we left off here, here's that optional testing script I wrote. And again, this written guide and all of the code is copy and pasteable. All you have to do is go to my website and check that out. So let's go ahead and get into this. All right, so the next thing we're going to implement here is going to be our WebSocket manager. And again, I've like prepared a implementation list version of the code here, just because there's no point in having me mistype all of these parameters and stuff. So we'll try to save time there. So we're going to create real-time communication using a WebSocket endpoint here, and this connection manager is going to facilitate that. And real-time connection allows users to exchange messages instantly without refreshing the page, which is nice. So you can think about that like how you would normally use your like Facebook chat, or maybe other systems like probably Reddit uses this as well with their chat features. So it's basically like a phone call. So like both parties can talk and hear each other simultaneously. There's neither one of them have to like refresh the page in order to get the new information, in order to hydrate the data that's in their chat logs. In web applications, this typically is achieved using WebSockets, which is just a protocol that's kind of like layered on top of HTTP. It's actually just still HTTP, but it's just layered above that. It's like an upgraded connection essentially. It's a protocol that maintains an open connection between the browser and the server, the client browser and the server, which allows data to flow unidirectionally, which makes WebSockets perfect for chat applications, live dashboards, gaming, and different kind of collaborative tools. Like if you've seen those like the VS Code extension where you can like live code one with somebody else over, you know, and both of you type at the same time, that's done using WebSockets. And then how this connection manager is going to work is basically like the heart of our system here, and it just manages all the WebSocket connections and handles the message routing. Its core responsibility is going to be to track the active connections, route messages, handle join and leave events, and then broadcast updates to all users. So the active connections is going to be the way that we store our WebSocket object for each connected client, and this is going to hold some complementary data about the user. So it might hold the username and then, you know, whether or not they're online. Our first method here, we're going to do user ID is going to be equal to user ID, user.id, which is something that we're going to get passed from the actual connection itself. And then we're going to do self.active, not capitalized, self.active connections. At user ID is going to be equal to that WebSocket object. And then we'll change that to little metadata dictionary we have. Yes, user info at user ID. We're going to give them the username and then whether or not they are online. And that needs to be a Boolean, not a string. And then we will need to send a join notification to all the other users and then update the online user list for all the connected users as well. So we will await. We haven't implemented this yet, so we'll do await self.broadcast join notification, and that's going to be user ID, username, and we are also going to await the self broadcast online users update, and that's just we'll implement this down here, but we don't need any parameters for that currently. And then the disconnect. So this is going to remove them from the connection registry, but it's not actually going to disconnect them. So we'll do, if user ID is in self-active connections, then we need to go ahead and delete We'll do this separately. So then we'll delete the active connection at the user ID. We'll do another check here to delete from the other dictionary. So if user ID is in self.userinfo, then we will go ahead and delete it from there as well. And then we're going to return none. So this is not expected to return anything. And then we don't need this either, because we'll do that in here. And the disconnect user implementation will, so here we're just going to actually call that function we just wrote. So it'll be self.disconnect, yep, user ID, and then we'll broadcast that to all the online users. And then to send a personal message. So if user ID is in self.active connections, we'll take the, we can simplify this actually. So we'll just take this, put it here, take that away. So if the user ID is in this, yeah, user ID from the self-active connections, we'll send that message. And we need to actually use the Python library JSON for that. So we'll do json.dumps. Yeah, that's correct. Message. We will try this. The reason that we're accepting this is in case the user disconnects while we're in the middle of this function, which isn't likely, but is possible. Essentially, the connection just might be closed. We'll pass that here. Oops. And that's just if the connection is closed. And then the broadcast message. So essentially, we're just going to, this is if we ever need to broadcast any notification to all the users. So like on a join notification or possibly a leave. All right, and then to broadcast message, and this needs to be changed to this. We could have done that, but just in my notes, I have it this way. So we'll go ahead and create that join message, which will be join message, will be from user join message. And it's going to be with the new user ID. So user ID is going to be the new user ID, and the username is going to be the new username. That's going to complete that user join message, and that user join message comes from the schemas.py, which is right here. And then this is set as a default here, right? So we've got this default, so we don't need to include that here. And then we are going to not send that to the new user and send it to all the other connections. So for user ID and self.active connections, we are going to, if the user ID does not equal new user ID, then we're going to send that. So we're going to send that join message to all the other users except for the user that is the new user. Now we'll implement the broadcast message, which will just broadcast a message to everybody. So we'll disconnected users is going to be an empty list, and then we'll do for user ID and connection and self connections.items. We will try, and we're going to do send text here. So let's go ahead and get rid of this. Just try to send text and then use json.dumps to create a string representation of the dictionary. And I guess I should import that. There we go. And on exception, we'll add the user ID that we accepted on to our disconnected users list. And then we will clean up anytime that this exception is thrown. We will go ahead and clean up the disconnected users. So for user ID and self.connected, or sorry, for user ID and disconnected users, we will disconnect that to user using their user ID. So when a user joins, we're going to need to notify all the other users that somebody joined. So we'll implement that here, and we'll just go ahead and create that join message object. So we'll do join message, yeah, and then this also comes from our schemas here. So user join message, and we have a default, so that doesn't need to be included. We can get rid of that, and then we'll have user ID equals new user ID, and username equals new username. It's all got an int here and a string here for that. And then we will only broadcast that information to the other users and not the new user that just joined. So for user ID and connections, and we'll change this a little bit. We're going to use keys. And then if the user ID does not equal new user ID, then we are going to wait self.send personal message, and we'll use that. We don't want to use dict. We're going to do model dump, which comes from Pydantic. Oops, if I can type, please. There we go. So we'll get that join message model that dumps to basically a string representation that we can send, and we'll send it to that user ID. And then we will broadcast online users update. So anytime, so now we'll implement this method here, which just broadcasts any updates to the online users. So we will, for user ID in self.active connections.keys, our online users will be self.get users online, and we'll exclude the current user. And then we will create this user message, which comes from here. And we will send a personal message as well. Essentially what this does is it sends a customized online user list to each connected user, excluding themselves from their own view. So we'll return the online users as well using a fancy list comprehension. So we will return the dictionary. Yeah, user ID is going to be user ID, username is going to be info username. For the user ID and info in self.userinfo.items, if user ID does not equal the excluded user ID. And we don't need this part. At all. We just need to close the list. So for handling the WebSocket message, so you can imagine we're going to get some HTTP information, and it's going to look something kind of like this, where we're going to have a type, and it's going to have a value, and a user ID is going to have a value, and the content is going to be some string value. So that's essentially what we're going to do. We're going to kind of deconstruct that JSON string, and then use that to build objects in Python. First, we're going to get to the message type. So message type is going to be data.getType. If the message type is message, then we're going to do some exception handling here. We're going to try to validate the message using the Pydantic schema. So we'll do chat message is going to be, we're not going to do this deconstruction here. Oops. Let's get rid of that. We're going to actually build that object here. So content is going to be data.content. User is going to be the user ID, and the username is going to be self.userinfo on the key user ID, and we're going to get the username out of that. And then we will then broadcast we're going to broadcast a validated message. So we'll do await self.broadcast message. Oh, I see what I did. Yeah, we're going to have to change that and change that. So we'll broadcast the model that we get from Pydantic here. This will handle this, and then we'll handle any exceptions that might happen, which could be, I think we have some constraints here. Where are we? Yeah, so the chat message, we were restricting that to be 1 through 1,000 characters long. So that could cause an exception here, and then we're going to need to return an exception. So we will error message. It will be error message in message file format. We don't necessarily need that. The message actually will be, because this is the only restriction that we have, is that the invalid message format for content is too long. And oops, we should probably make that a correct string. Spell things right. And then we don't need this, and that's the detail, right? No, that's the message. And then we will await the send personal message, error message model dump with the user ID is correct. And then we will also handle for other message types. The other one that we have is get online users, in case a user connects and then is asking for which users are online, the client code anyways. So then we can implement the WebSocket route here. So the first thing that we do is accept the WebSocket connection, and then we're going to verify the token and get the user. So from the database, we are going to get the, so this is essentially, it's like the generator function that FastAPI uses to handle with the depends object. So it just opens a session and injects it into the route. So I think I actually misspoke when I talked about that when we defined it here, but that's what this is, a generator that does exactly that. So we're going to get the DB as a dependency injection, and then we are going to verify the token using the token that's provided, passed in from the client and the DB that we just got. And if the user doesn't exist, then we have a policy violation. Essentially, that could mean that somebody for some reason, maybe the JWT has been intercepted, or somebody copied it and is trying to do nefarious things with the server. So we're going to try to catch that, and then pass them the status code, and then otherwise we're going to need to add the user with the WebSocket manager, which we do like this. And then we're going to otherwise we're going to need to do a loop just to continuously manage the And then we're going to use a loop to continuously handle that bidirectional communication flow. So we're going to try while true. The data is going to be the WebSocket.receive text. And then we're going to, don't need this import JSON, but we'll get rid of that in a second. We've got this data dict, which is going to be loaded from that data using JSON, the library. And then we are going to await the manager.handle WebSocket message. And then we're going to pass in the actual WebSocket object here, and then give it to that user ID and the data dict. And then otherwise, that means that the WebSocket has otherwise failed or disconnected. We're going to accept that WebSocket disconnect, and then use that manager class to disconnect the user with that ID. So if we just get rid of that, this should be imported up here. Import JSON. Beautiful, beautiful.